In this video, I want to look at inverse trig functions. So let's start with a reminder of what inverse functions are. Inverse functions, f and g, have the property that f of g of x is equal to x and g of f of x is equal to x. There are ways to undo functions. It does the opposite of the other function. So let's look at how this relates to trig functions. Let's suppose I have this triangle here, and I call this angle here A. And I want to know what sine of A is. Well, sine is opposite over hypotenuse. So in other words, sine of A is 1/2. However, what if I want to know the opposite? What if I want to know what the angle measure of A is? So essentially, I've already said that I know sine of A is equal to 1/2. But what is A? Well, the way we denote this is by what's known as arcsine of 1/2 is equal to A. And what this notation means is what angle has the property that sine of A is equal to 1/2. So I know the result of the trig function, and I'm trying to determine the angle. And in this case, we actually get that the angle measure is pi over 6, or 30 degrees. So we were able to kind of figure out what the sine was, and then we have to reverse engineer what the actual measure of the angle is. And we know it's pi over 6, or 30 degrees, because we know that sine of pi over 6, or sine of 30 degrees, depending on if you're in degrees or radians, is going to be 1/2. Let's take a closer look at arcsine and arc cosine. Arcsine has a domain of -1 to 1. These are the only numbers we can input into arcsine. And this is because sine of any angle has to be between -1 and 1. So the domain here, the numbers that we input, are between -1 and 1. Since the graph of sine actually does not pass the horizontal line test to have an actual inverse, we have to restrict the range of arcsine, and we're going to restrict the range to be -pi over 2 to pi over 2. So anytime we're taking arcsine of a number, our solution will be between -pi over 2 and pi over 2. For arc cosine, our domain will once again be between -1 and 1. However, for cosine, our range is between 0 and pi. Let's consider arctangent and arc cotangent. For arctangent, our domain will be -infinity to infinity. This is because the graph of tangent actually has a range that goes from infinity to infinity. Our range here will be -pi over 2 to pi over 2, because between -pi over 2 and pi over 2 is actually one piece of my tangent graph. So if I were to give a rough sketch of a tangent graph, it looks something like this. And it repeats indefinitely. We're only going to look at the center piece between -pi over 2 and pi over 2. For arc cotangent, once again, our domain is -infinity to infinity. And this time, our range is between 0 and pi, because once again, if you graph cotangent, that's going to be one piece of it like this. Just like we took one piece of tangent, we're going to take one piece of arctan between 0 and pi. Next, let's look at arcsecant and arc cosecant. For arcsecant, my domain is going to go from -infinity up to -1, as well as between 1 and infinity. So I need numbers that are bigger than 1 or less than -1. My range goes from 0 to pi over 2, as well as between pi over 2 and pi. So we have this break at pi over 2 because cosine of pi over 2 is 0, and arcsecant is 1 over cosine, so it's actually not defined at pi over 2. So we do have a break in our range here. For arc cosecant, our domain is once again -infinity to -1 and 1 to infinity, which is exactly the range of cosecant. And then my range here goes from minus pi over 2 to 0, as well as 0 to pi over 2. And once again, we have this break at 0 because it's actually not defined at 0. Cosecant is not defined at 0. So let's look at using these. Here, I want to know what the angle A is. So the pieces I have is I have the opposite and I have the hypotenuse. So that tells me I'm most likely going to use sine. I know that sine of A is opposite over hypotenuse, which reduces to 4 over 5. So what I want to know here is arcsine of 4 over 5. And we can actually use a calculator to find these for us. When we do, we get approximately 0.927 radians. So the measure angle of A is approximately 0.927 radians. This time, I have the adjacent and the hypotenuse, so I'm probably going to want to use cosine. Cosine of A is adjacent over hypotenuse, so I need to know arc cosine of 3 over 10 is equal to the measure of angle A. And using a calculator, I get this as approximately 1.266. So the measure of angle A is approximately 1.266 radians. Since these are inverses, they can undo each other. It's important to note that if we take something like arcsine of sine of x, this is just going to be equal to x. Similarly, something like secant of arcsecant of x will just be x. So these are meant to kind of undo each other. Sine, cosine, tangent, cosecant, secant, cotangent, all input an angle and output a number. All of my inverse trig functions, arcsine, arccosine, arctangent, etc., input a number and output the appropriate angle.